So this is one of my latest prototypes of an in-flight deployable drone. The mechanics is rather simple, and the actual concept will have some automatic deployment system that detects when this is, for example, folded, and then it deploys and starts flying autonomously. But this first phase is to make sure that I can actually change the geometry of the arms during flight. So we have right now, I just have a manual deployment, so I have a potentiometer that I can actually change different arm geometries. This is fully deployed, and I can fold completely and unfold completely, or stop at any point, stop here or stop here. So it's very adjustable. The speed right now is slow because the idea is to fly it, to try to see how I can adjust the flight controller parameters so that it flies with different geometries. So I don't want it to the idea is to start flying like this right now, and then in flight change the geometry and fold it a bit, keep flying, fold it a bit, keep flying, and see when the drone how stable I can keep the drone with arms partially folded. This is half folded, this is a bit more folded. So I have a potentiometer to adjust this and do the tests. But as I said, the idea is to actually drop the drone in tight spaces, folded, then automatically with an IMU or through timing. There are different alternatives. Automatically the drone will deploy the arms at much higher speed, obviously, than what I'm doing now. This is slow for the reasons I mentioned about for the first tests, and then perform an autonomous inspection or mission. And then I'm designing a recovery system as well, so that the drone can come back to the entrance of the tight entrance, and then be extracted, foldable, obviously, as well. This will be next phase. I'm waiting for some hardware to arrive, actually. So looking forward to make some tests with different arm geometries and see how stable I can get it. Yeah.